So, have you ever been online searching, maybe typing in exactly what you think you're looking for? You just know it's out there somewhere.
Oh, absolutely.
But the search results you get back are just, well, completely useless. Like you're using plain English, perfectly natural language, and the search bar seems to be, I don't know, speaking a different language entirely. Happens to me all the time.
It's super frustrating, isn't it?
Yeah.
And it really highlights what Carrie Rich over at LucidWorks said. She's the VP there.
Right.
She put it really well. Today's customers expect LLM-level intelligence in every digital interaction. You know, LLM, large language model intelligence.
That deep understanding.
Exactly. Understanding context, nuance, not just, isolated keywords. And that's where traditional search just often really misses the mark.
It's a massive gap, and that's exactly what we're diving into today. We've got some fascinating sources that really unpack how AI is, well, completely changing the game for online search.
Yeah, moving way beyond just matching simple words.
Understanding your actual intent.
Right. So our mission today really is to explore not just why this change is so badly needed, but also how it actually works under the hood.
And what are the benefits? For businesses, sure, but maybe more importantly for you, the person actually trying to find something online.
Definitely.
Okay, so let's make this concrete. Let's use a scenario our sources brought up. Imagine someone, let's call him Ryan Koji, searching an online store for shoes for rainy weather. Simple enough query, right?
Seems simple.
But with a traditional keyword search, what's the likely problem there?
Well, the old system would probably just grab onto rainy or weather keywords, but it doesn't get the context right. It doesn't understand the intent.
So what might it show instead?
You could easily end up with like canvas sneakers, maybe canvas showed up somewhere, or even formal shoes if the word weather was in some random part of the description.
Stuff that's completely useless if it's actually raining.
Totally useless. The system just can't connect the dots between rainy weather and, waterproof.
And that really is the core issue, isn't it? It's not about getting any result. It's about getting the right one.
Precisely.
So the whole point of this AI agent framework we're looking at is to completely fix that experience. It's built to actually understand natural language.
How humans talk.
Yeah, map what you mean to the right product descriptions and give you back results that are what the sources call high recall and contextually spot on. High recall meaning it finds pretty much all the relevant stuff.
And this is where it gets cool. This is the aha moment. For that same search, shoes for rainy weather.
Right.
The intelligent agent doesn't give you canvas sneakers. It gives you semantically relevant results. Things like waterproof boots, maybe rubber loafers, weather-resistant sneakers.
Because it understands the meaning behind rainy weather.
Exactly. It gets the message, not just the words. Big difference.
So, okay, how does that actually work? Give us the high-level view. What's the journey from me typing that query to getting that smart list of products?
Okay, so first up is query ingestion. The system takes in your natural language query, just as you typed it.
Got it.
Then it goes through NLP pre-processing and vectorization. NLP is natural language processing. This bit's crucial.
This is the AI part.
This is where the AI really kicks in. It transforms your words into something called a semantic vector. You can think of it like a numerical fingerprint, or maybe like coordinates on a map of meaning.
A mathematical representation of the meaning.
Pretty much. And the sources really point to Snowflake Cortex being key here for creating these embeddings. It turns language into numbers the computer can work with.
Okay, so you've translated my messy human language into this precise vector. What's next?
Next comes mashing and ranking. Your query vector gets compared against vectors for all the product descriptions in the catalog.
How does it compare them?
It uses math, specifically something called cosine similarity. Basically, it measures how close the meaning of your query vector is to each product vector. Think of it like measuring the angle between them on that meaning map.
Smaller angle, closer meaning.
You got it. So it finds the best matches based on meaning, but then it does something else smart. It re-ranks those matches. It might use other data like sales figures or customer reviews.
Oh, interesting.
To push the best overall results to the top. Not just the closest meaning, but maybe the most popular or highest rated among the relevant options.
So relevance plus other business factors. No, what's really interesting here, you mentioned this whole thing is built inside Snowflake. The sources say it's fully governed and scalable. Why is that such a big deal? Can you give an example of the headache this avoids?
Oh, it's a huge deal. Think about a big company, right? Often their data is all over the place.
Right.
Some product info here, sales data there, maybe some stuff in the cloud, some still on old servers.
Data silos, nightmare.
Exactly. Trying to build a consistent, secure, reliable search on top of that mess. Forget it. Compliance is tough, security is patchy, performance is unpredictable. By building it natively in Snowflake, everything's in one place. Your product data, your customer data, the embeddings, the search logic itself, it's all under one roof, governed by consistent rules.
So easier compliance, better security.
And that scalability is baked in. It can handle huge spikes in traffic like Black Friday just as easily as a quiet period. It avoids so many infrastructure headaches. It brings the data and the intelligence together securely.
Makes total sense. So what are the specific Snowflake tools doing the work here? You mentioned Cortex.
Right. Snowflake Cortex is absolutely central. It's not just turning your query into a vector. It does the same thing for every single product description in the catalog.
Ah, so everything gets a meaning fingerprint.
Exactly. It creates that description embedding for each product. Then you've got Snowpark Python. That's used for things like cleaning up the data before embedding, and also for implementing that smart re-ranking logic we talked about using sales or reviews.
Okay, and what about the part I actually see? The search box.
That's typically built using Streamlit in Snowsight. It gives you that nice user interface right there within Snowflake, where you type your query and see the results.
And where does all this product info, the name, description, price, and its vector actually live?
That lives in a hybrid table. It's a special kind of table in Snowflake designed specifically to hold both traditional data like text and numbers and these new vector embeddings side by side. It's the main index for the search.
Gotcha.
And the sources also mention some optional extras, like using an external function to maybe call out to another AI model like OpenAI for embeddings in real time if needed, or using tasks and streams to automatically update the index whenever product info changes. Keeps it fresh.
Okay, let's bring this back to the example. The sources listed products like waterproof boots, rubber loafers, canvas sneakers, hiking shoes, formal shoes. How does the query shoes for rainy weather actually connect specifically to waterproof boots? I mean, it seems obvious to us, but how does the system know?
It goes back to that cosine similarity. When shoes for rainy weather gets turned into its vector, its numerical fingerprint.
Right.
That fingerprint is mathematically very, very close to the fingerprint for waterproof boots and rubber loafers. They occupy a similar spot in that high-dimensional meaning space.
They're conceptually nearby.
Exactly. The system calculates the distance or angle, finds the ones with the highest similarity score, the closest meanings, and those pop to the top. That's the intelligent connection it makes.
Okay, that sounds powerful for understanding meaning, but, real-world search is messy. What about typos? Or maybe my voice assistant butchers what I say. Does this super smart system just, break?
That's a really practical point. And no, it doesn't just break. This is where hybrid matching comes into play.
Hybrid, meaning more than one method.
Right. The sources talk about using a fallback mechanism, like a phonetic algorithm, so something like SoundX. So even if you misspell shoes as, say, shoes, or your voice input hears it weirdly.
Which happens all the time.
All the time. The system can still figure out you probably meant shoes based on how it sounds. It then combines this phonetic match with the semantic understanding from the vectors.
Ah, so it's got a backup for spelling and sound issues? That makes it more robust.
Much more robust. It anticipates how people actually search, mistakes and all.
And can you get even more specific? Say, I only want footwear, not, waterproof bags, and I want them under $100.
Absolutely. That's where metadata filters come in. You can easily add filters based on the standard product data.
Like category or price.
Exactly. So you can say, show me results only in the footwear category, and then maybe sort them by price ascending after sorting by relevance. It gives you that flexibility to narrow things down based on other criteria, not just the meaning. Context plus practical filters.
Okay, so pulling this all together, what's the real business impact here? Beyond just being clever tech, what does this AI-powered search actually do for a company's bottom line?
Well, the core insight isn't just finding more stuff, it's finding the right stuff. Way more accurately. Think about how many searches on traditional sites just return 0 results found.
Yeah, the dreaded 0 results page.
It's a dead end.
Yeah.
This kind of system drastically reduces those, especially for longer, more conversational queries, what they call the long tail, people asking questions naturally.
So better search accuracy.
Much better accuracy, which leads directly to better product discovery. People find things they wouldn't have found before. That means a better user experience overall.
Happier customers.
Happier customers who are more likely to buy. So you see increased conversions because the recommendations are genuinely intelligent and relevant. It basically turns frustration into finding what you need fast.
And thinking a bit broader, what are the other advantages beyond just that immediate sale?
Well, first, it enables that true semantic understanding. The system gets vague queries, natural language, that's huge. Second, the fact that it's all governed and scalable within Snowflake is a major strategic plus.
You own your search intelligence.
Exactly. You're not relying on some external black box.
Yeah.
You control the data. You understand customer intent better. Plus, that hybrid matching means it can handle multiple languages or misspellings much better, making it more adaptable globally.
And looking ahead, the sources mentioned some cool future extensions. What's next for this kind of AI agent?
There's a lot of potential. They're talking about multilingual search.
Yeah.
Imagine searching in Spanish and finding the right product, even if its description is in English. Seamless.
Wow, okay.
Then there's personalization. Using a profile built from your past searches and clicks your own unique interest vector to tailor results specifically to you.
Even more relevant.
Right. And critically, building feedback loops. So if you search for something and click the third result instead of the first, the system learns from that. It continuously fine-tunes the embeddings and ranking based on real user behavior, getting smarter over time.
That makes sense. Constantly improving. Now, with all this powerful AI, the questions of trust and transparency always come up. How does Snowflake help ensure this system is reliable and performing well? What's built in?
Yeah, that's super important. Governance and observability are baked right into the Snowflake platform.
Okay.
So things like query logs are stored securely in audit logs. You have a clear record of every search for compliance or debugging. You can set up alerts for problems, like if searches start failing or returning low-quality results.
Proactive monitoring.
Exactly. Businesses can build custom dashboards to track search quality metrics in real time. And crucially, they can detect what's called model drift.
Model drift. What's that?
That's when the AI's performance might slowly degrade over time, maybe because customer behavior changes or the product data shifts. The system can help spot this by logging poor results or times when users override the suggestions.
So you can retrain or adjust it, keep it sharp.
Precisely. Plus, combining different scores, like the phonetic match score and the semantic similarity score, actually helps with explainability. You have a better idea of why a certain result was surfaced.
So wrapping this up, how does this agent-driven search really change the game for discoverability, for finding things online?
It fundamentally redefines it. By embedding this language intelligence directly into that governed Snowflake environment, you're marrying semantic power with platform simplicity.
Understanding intent, not just words.
Right. It turns what the user means into a conversion much faster, much more effectively. It's less like a database lookup and more like having a really smart assistant who understands you.
Which leads us to a final thought for you, our listener. Think about this. How might this level of really intelligent search change your expectations? Not just when you're shopping online, but really for any digital interaction where you need to find information.
Yeah, anytime you're looking for something.
Even if your query is kind of vague or conversational, what other fields, what other industries besides e-commerce could be totally transformed by this deep understanding of natural language? It really makes you wonder about a future where our digital tools don't just process keywords, but actually engage in a kind of conversation, truly understanding what we're trying to achieve.